Hello YouTube, it's James, 20BMI, and this video I'm just going into repeaters a little bit, and how they work. What you're looking at here is the Arcom 210 repeater controller. This is a sophisticated repeater controller. It's an American based controller. You can buy this kit form or ready built, assembled. I bought this one assembled. UK price retailing at about £200 for the assembled and £150 for the kit. Now this repeater controller includes speech. You can record your own speech with these ISD chips. There's an ISD chip there, that's a voice recorder. It's got multiple DTMF decoders. The best thing this repeater controller has over most other ones is it has 3 ports, which enables you to run 3 repeaters at the same time, or duplex, or remote base, or whatever you want to run. It does support remote base. I'll just turn that down, sorry about that. Now the I/O port is for fan control and other accessories you can add on, which are all programmed. This can be PC programmed. You just have to wire up a serial COM port to them wires there. You've got your TX, ground and RX data. You obviously got all your pots here to adjust audio and whatnot. And this will hook up to nearly every kind of radio. Some radios you may need to use interfaces to connect them up to, but it's pretty much plug and play. So, how does a repeater work and what's it about? These diagrams, you have to apologise, are not very good. So you've got an antenna, and I'll just quickly go over that repeaters are usually based high up in high up areas to receive other signals. And repeaters always work on a duplex frequency unless it's a simplex repeater. Most repeaters in the UK on 2 meters are 600 MHz shift downwards, and on UHF they're 1.6 upwards. And there are also now 7.8 shifts on UHF that are plus shifts. So you have an antenna, you have a duplexer. So you're using one antenna, so the duplexer splits to transmit and receive, obviously because it's doing it simultaneously. You got your antenna. You have your if you're just using one radio, which is a transceiver, then you'd have your transmitting line and your receive line coax, and then you have what we call a piggyback controller for IDs, courtesy tones, and DTMF decode and remote shutdown. So your transceiver would be there, your duplexer antenna. Now in another scenario, everything's the same, that's the duplexer and the antenna, but the difference you could have is that you might be using 2 mobile radios, so then you just use a controller. And that would then, you can have your receive and transmit radios, the controller in the middle, and the controller, obviously as soon as it receives, the controller will indicate that it's receiving, key up the other radio, IDs if the over is quite long or whatever, and courtesy tones and remote shutdown. And down here we have dual antennas, which is also quite common in repeater worlds, and cavities. And cavity basically is a filter to filter the transmit away from the receive, so you can use dual antennas, which is also quite useful if you want to use a beam and say an omnidirectional antenna. And obviously here you just have your transceiver and a piggyback controller. So that's pretty much how a repeater works, and repeaters are very useful. Repeater controllers you can make quite easy if you just let's grab this. Obviously here in the UK I'm not legally allowed to run repeaters, but I do testing with dummy loads, which is another thing I made was a dummy load, which just is 2 100 ohm resistors in parallel. And that's good for about 2 watts. So, but that's just for testing. This is a repeater controller I made using a pickaxe board, and there's the pickaxe. That's the 18X, and this is just a project board. So I'll just go over what the circuit is. You can't see that well. I will apologise. My camera's not the best. I'm using the BlackBerry Bold. Okay. So obviously you've got your pickaxe here. That's the brains. You've got your power inputs. That's all board standard. Now, this is the beep circuit, the filtering circuit for the tone output from the pick. Here we have 10N I just had to check there because I've forgotten 10N ceramic capacitors, and a 10k resistor and a 1k resistor, which then goes into a, I believe, that's a 500k pot there. That's obviously for your loudness adjustment. What I am going to add on this is a NPN transistor that with some resistors, so that when an over's going, the ID will be quieter over the audio instead of the same pitch. This way it just makes listening to the other person's audio much clearer and nicer. Here is the transmit and receive circuit. Up here we have the PL, I'll just go over this. This is the PL enable and disable circuit. Basically, you line this up onto the PL and disable I'll get it right. PL and disable and enable circuit on the radio, and when the repeater's in beacon mode, which is a requirement in the UK, this will ground out that, and that will ground out the PL, so that you don't have to listen to courtesy tones if you've got CTCSS decode on. So it basically switches off the CTCSS. Now here, this bank here is to receive. So if you've got when the receiver's receiving and it puts a 5V output, you put that through this NPN transistor, which then is wired to the PIC. And this basically just creates a ground onto one of the PIC pins, and the PIC then knows that the repeater's in use. And the transmit is basically the same, but the other way around. 5V comes from the PIC into a 1k resistor, into the NPN, and then causes a ground on the collector base, which is hooked up to the transmit line on the radio. So this is a very, very basic piggyback repeater controller. My mate Jake, G1YFF, does more advanced controllers building. He actually has repeaters on the air. As I said, when I get my full license, I'm thinking about doing something like this. But for now, it's just fun playing around with them and seeing what I can do. Alright, this is just a quick video on repeater controllers and repeaters themselves. And I'll say 7-3 for now, and we'll catch you all later.